We'll start with Chapter 5, Section 3, Evaluating Definite Integrals. So here is the first theorem, evaluation theorem. Suppose you are given f to be any continuous function on the interval ab, then you're trying to evaluate integration of this function f from the interval a to b dx. So this is also area under the curve. You know this from the previous section. And before area under the curve, we did calculate this by summing up the area of rectangles. So this integration can be referred to area under the curve or summing up the area of rectangles. Now you're seeing one more formula for this, which is FB minus FA. So how did we get this? Integration of a small function, lowercase f, is always capital F. As soon as you get the lowercase f to capital F after integrating, which means you're integrating some function and the new function is capital F. You have to evaluate this from the lower limit to upper limit, a to b. So always it's the upper limit. So upper minus lower. Calculate f at b minus calculate f at a. So here we call this capital F is the antiderivative of the small f, and we are familiar with this from section 4.9. Let's do this example. Evaluate the following integrals. So integral of each of this function, you have to distribute this integral signs for each of this function. So integration of x to the 4 is x to the 4 plus 1, which is 5 divided by 5. 3/4 is a constant. Integration of x square, x to the 2 plus 1 is 3, the same 3 you want to write in the bottom. Plus 2/3 integration of x. Integration of x is x to square divided by 2, so write the same. Integration of 1 is just the function x, so write x. Now the formula, what I have used this here is this one. Integration of x to the n dx is x to the n plus 1 over n plus 1. I've used this formula at least 4 times here in this equality sign for every expression on the top. So in these type of problem, you read the question carefully. It says evaluate the integral. When you're evaluating an integral, you will be given some limits here, upper limit, lower limit. So you don't have to write that plus c, which is the integration constant. Rather, writing than a plus c, you will put a slash line, write the lower limit 0. This is given for you in the integrand. Write the 2 upper limit. This is given for you in the given problem. Lower limit 0, upper limit 2. Now, understand that it's always upper limit minus the lower limit. So, evaluate the function, what you integrated here on the top, this entire function here with respect to the value 2. So, evaluate it at 2. So, this is 2 to the 5 divided by 5. 3 can cancel. You have negative 1/4 2 to the 3. 2 cancels. 1/3 2 square and then 2. So all this is your upper limit minus the lower limit. Plug in 0. The first value 0 to the 5 over 5 is 0. The second value is 0. The third value is 0. The last value is also 0. Every variable has a function, like every function here on the top, you see the common variable which is x. So when you plug in x equal to 0, the entire term becomes 0. Simplify this expression and you will see that you get 56 over 15. So it's always upper limit minus the lower limit. Let's do one more example. Distribute this integral for each of these functions and start integrating. So it is 2x square divided by 2. Integration of any exponential function is the same, e to the x. Integration of 4 cosine x. Integral of cosine is sine, so I'm going to write this as 4 sine x. Evaluate this from negative 1 to 0. So you understand that 0 is your upper limit and negative 1 is your lower limit. And you also understand that it's always upper minus the lower limit. So let's evaluate the function. Plug in 0. The first value of the function will be 0. You cancel these two. 0 square is 0. And then negative e to the 0. And then you have 4 sine 0. So wherever you see this x variable, you will plug in x is 0. Minus the lower limit. This is upper, this is lower. Plug in x equal to negative 1. So this becomes negative 1 the square. And then you have negative e to the negative 1. And then you have 4 sine of negative 1. Let's simplify each of these brackets. The first one, e to the 0 is 1, sine 0 is 0. So when you simplify these three terms, you have just negative 1 from the top. The next one, I have a negative sign, so let me write that negative sign. Negative 1 the square is 1, that's this term. Negative e to the negative 1 can be written as negative 1 over e. E to the negative 1 is 1 over e. Negative, let me use a trigonometric formula to simplify this. Sine of negative theta is negative of sine theta. So I have sine of negative 1. I'm going to write this as negative sine of 1. So still I have a coefficient 4. So let me bring down that. So let me distribute this negative sign. If I want to take off this bracket, I have to distribute this negative sign to each of the terms. So let me distribute it. So it's negative 1, positive 1, positive, sorry. Negative times 1 is negative 1, positive 1 over e, positive 4 sine 1. So simplify, you have 1 over e plus 4 sine 1, and then you have negative 2. So first integrate the given function and then evaluate the function at the upper limit and then the lower limit. Always understand it's upper minus the lower limit. The next one, integral of 1 plus 2y square. First I want you to FOIL this. So this is 1 plus 4y square plus 4y. Now you are good to integrate after you FOIL it. So let's integrate. Integral of the first function 1 is just y. Integral of the second function 4y cubed divided by 3. Integral of the third function 4y square divided by 2. Evaluate this from 1 to 2. So understand that this 2 is the upper limit, 1 is the lower limit. You always do upper minus the lower limit. So let's do it. So when you plug in the upper limit, it's going to be 2 plus 4 thirds, the 2 cube, plus 4 over 2 can be written as 2. So you can write 2 times 2 square. So all this is your upper limit. Minus, you want to write the lower limit. Evaluate variable y at 1. So it's 1 plus 4 third times 1 plus 2 times 1 square. So when you simplify these two fractions, you see that you get 2 plus 4, 2 to the 3 is 8. 4 times 8 is 32. 32 divided by 3. 2 times 2 square is 8. Negative 1 plus 4 thirds plus 2. So you have two fractions, you want to add them. You can multiply this negative sign to each of these fractions. Then you can take off this bracket. So you have 2 plus 32 over 3 plus 8. This 2 plus 8 can be written as 10 here. And then you have this 1 plus 2 can be written as 3 here. So I'm going to write negative 3. I'm multiplying the negative 4 thirds. Again, this 10 and 3 can be written as 7 when you subtract them. And these can be subtracted. So because you have a common denominator, so you write 7 minus 32 minus 4 is 28 divided by 3. Now you make a common denominator, multiply 3 to the first fraction. So you write 21 minus 28, which is negative 7 divided by 3. So this is the simplified answer, negative 7/3. So let's do this. Integration 3 to the x dx. You have to be familiar with the differentiation formula. So let me quickly review your differentiation formula. If I give you a function a to the x, I ask you to differentiate this function. We have seen in chapter 3, this is ln a to the x. This is differentiation. So now reverse of differentiation is your integration formula. So I have this function here. I'm going to integrate this a to the x. This is that a to the x which I will be integrating. Again, I'm integrating. So answer should be the ones on the left. So I will bring that here. This is your a to the x. But what do we do with this ln a? This goes for the division term. So I'm going to write this as division, a to the x ln a. So when you integrate a to the x, your answer is a to the x ln a. When you differentiate a to the x, your answer is ln a to the x. So let's do that here, integration formula. So this is 3 to the x divided by ln 3 after you integrate. Evaluate from 0 to 1, upper minus lower. So this is 3 to the 1 ln 3 minus 3 to the 0 ln 3. Simplify, 3 ln 3 minus 1 over ln 3. Common denominator, subtract the numerators, it's 2 over ln 3. The next one, evaluate x minus absolute x dx from negative 1 to 2. So understand that this is a line here, negative 1 to 2, and you are evaluating x minus absolute x. These absolute functions behave different. It's positive, absolute x is positive x for x greater than 0, and it's negative x for x less than 0. So this function, piecewise functions, is defined in a different way for a positive interval and for a negative interval. So you want to break this negative 1 to 2 into two halves. Say I'm going to break this at 0. The reason is absolute x behaves different to the right of 0 and to the left of 0. Now after breaking this at 0, let me write this as integration negative 1 to 0 x minus absolute x dx plus integration 0 to 2 x minus absolute x dx. Now that I'm defining this first integration from negative 1 to 0, I can use the definition for x less than 0 because you see the x values are negative 1 to 0. So this absolute x becomes negative x. So I'm going to write this as x minus negative x dx plus 0 to 2, and again I will break this as just x, positive x, because I have x values from 0 to 2, positive values, dx. So x minus x is 0. What is integral of 0 dx? Integral of 0 dx is 0. So you have only the first function to evaluate. Negative times negative is positive. So this is x plus x, which means you get 2x. So let me write integral negative 1 to 0, 2x dx is equal to, integrate this, 2x squared divided by 2, evaluate from negative 1 to 0, 2 cancels, so this is 0 square, upper limit minus the lower limit, negative 1 the square, upper minus lower, this minus is from here. Simplify, you get the answer as negative 1. The next one, find the general indefinite integral. As soon as you see this general antiderivative or general indefinite integral, which means your answer will have a plus c. And you also see that you are not given any limits here. It's not given. So you cannot find the c if it's not given. So first, let me multiply them out. And then let me find the product. 4 times 5, 20. 4 times x, 4x. Negative x times 5, negative 5x. Negative x times positive x, negative x squared. Simplify, negative 20 plus positive x, negative x squared. Now let me write integration of 4 minus x, 5 plus x dx is integration 20 plus x minus x squared dx. So now let me integrate every function here. So integral of 20 dx is 20x. Integration of x is x squared over 2. Integration of x squared is x cubed divided by 3, and then a plus c. Plus c because you don't have the limits of integration, and the question is asking you to find the most general indefinite integral. Indefinite, you don't know the definite answer, so you will have a constant c. Now let's do this example 3. The area of the region that lies to the right of this y-axis, that's this region here, to the right of the y-axis, that's this side, and to the left of the parabola, this side, that's the shaded region, x equal to 2y minus y square. The shaded region in this figure is given by this integral. So all the shaded region is this integral 0 to 2, 2y minus y square, and then you have a dy. You want to find the area of the region. You want to write this as area of the region, which is integral 0 to 2, then you have a 2y minus y square dy. Integrate the first function, you see you get 2y square divided by 2. Integrate the second function, you have y cube divided by 3. Evaluate this between 0 to 2. Then you have the first fraction as 4, and then the second fraction is 8 over 3. Evaluate at 0, you get 0, so the lower limit is 0. Simplify, you get 4/3 to be the area of the region. So one last example in this section. The water flows from the bottom of the storage tank at the rate of RT given by this expression liters per minute, where T ranges between 0 to 50. You want to find the amount of water flowing from the tank during the first 15 minutes. So you write amount of the water equals the rate function, which is RT. You want to integrate the function RT from the limit 0 to 15 because you want to calculate it for the first 15 minutes. Now write 0 to 15. The function is 200 minus 4t dt. So integrate this first function. You get 200t. Integrate the second function. You have 4t squared divided by 2. Evaluate this from 0 to 15. Plug in t equal to 15. You have 200 times 15 minus cancel this 2, and you have 215 square. Evaluate it at 0, you get 0. So write 0. Simplify this, you get 2550, and you know that this is amount of water and the units given in the problem is liters. So write liters. So the question is asking you find the amount of the water that flows from the tank during the first 15 minutes, and you calculated it to be 2550. What suppose if you were asked to find the amount of water that flows from the tank during first 23 minutes? The upper limit of integration will be 23. Do a similar procedure. In the last step, evaluate the function from 0 to 23. So you fix the limits of integration regarding like how many minutes are you calculating. Okay, so we did learn about definite integrals. So most likely you will not see a plus c in the answer until and unless like you have given the limits of integration. You will see a plus c in the answer only if you are asked the general antiderivative or the general indefinite integral. So we have a nice precise answer when we evaluate the definite integral. We'll end this section here.